Good day to you all. It's a pleasure to meet you all on this platform. I trust we are all doing good. So we are having a revision class in mathematics in each of the 5 themes. That is the number and numeration, algebra, arithmetic, geometry, and statistics. So first I will start with numeration. So the first topic we'll be looking at under numeration is going to be writing and reading of large numbers. Writing and reading of large numbers. How do you write large numbers? How do you pronounce? How do you read out large numbers? So now if you want to read or write large numbers, the best way to do it is by grouping these numbers into trees so that you'll be able to write and read out these numbers correctly. For example, let's say we have 1, 2, 3, so the way you are seeing these numbers on the board, will you be able to pronounce these numbers correctly? No. You have to group down these numbers into 3 so that you'll be able to read and write correctly. So if you are grouping these numbers correctly, this is what you are going to have for each of these numbers. You have 1, 2, 5, 8, then 3, 3, 4. Wow, it's not looking very good. So if you are pronouncing these numbers, then you're going to have 1,258,334. But we are having all these numbers all chopped up together like this. There is no way you'll be able to read or write them correctly. So the next number we are going to group these numbers into trees. Wow, so we pronounce these numbers. We have 6,888,352,925. And then the last number we have 5,289. This grouping helps us to read numbers correctly. That is writing and reading of large numbers. And mind you, large numbers are around us. Let's take for instance a stadium. In a stadium, you can see a very large amount of people. You see the footballers, those that came to watch football. Let's say in the hospitals, we have different departments. We have the lab, the ward for either the pediatric ward, the male ward, the female ward. All these places you find a very large amount of numbers. Also in schools, yes, in schools you can find large amounts of numbers. So these are places in which you can find very large amounts of numbers. So mind you, the concept is what? Grouping numbers into trees for you to be able to read and write numbers correctly. So the next topic under numeration is going to be place value. We'll be looking at place value. Place value. So the next topic under numeration is going to be what? Place value. Like if you write out numbers, you need to know place value for each of these numbers you've written down. For example, let's say we have example 1. For instance, let's say we have so for you to know the place value of each of these numbers, you have to write down the placeholder for each of these numbers. The placeholder for 5 is what? Is million. for 2 is what? 100,000. Place value for 8 is 10,000. Place value for 2 is 1,000. Place value for 9 is 100. Place value for 2 is tens, and then place value for 5 is units, 1. Now, let's read out these figures. We have 5,283,000. You know they are all in thousand. 283,000. They are all in thousands. So now, you pronounce it together. 283,925. 5 is a unit, like 1. Single on its own. So now, for you to know the place value of the figures or digits, you need to like write out the placeholder for each of these digits or figures. So the next revision we'll be having under numeration is going to be Roman numerals. So Roman numerals are what? And what's it called? Numerals, we use it to represent Arabic numerals. And then we have 7 Roman numerals, that is, they are the building blocks. We have I to be 1, we have V to be 5, X to be 10, L to be 50, C to be 100, D is 500, and then we have N to be 1,000. So these are the building blocks. We have 7 Roman numerals, 1, 2, 3, 4, 5, 6, 7, and they are the building blocks. So we have rules in writing down Roman numerals. Rules. The first rule is that when a smaller Roman numeral is before a bigger Roman numeral, in this type of situation, you subtract the smaller one from the bigger one. So let's take a good look at these 2 Roman numerals. Let's say we have IX. I is 1 and X is 10. So and I said when a smaller one comes before the bigger one, it means you have to subtract the smaller one from the bigger one. So we subtract 1 from 10. So it's going to be 10 minus 1. And you're going to have 9. That's rule number 1. Then rule number 2. When the smaller Roman numeral is coming after the bigger one, it means you add the 2 together. So for example, let's say we have VI. V is 5. I is 1. So when the smaller one, which is I, is coming after the bigger one, which is V, it means you have to add the 2 Roman numerals together. So we are going to have V, which is 5, plus I, which is 1. So 5 plus 1 is going to give us 6. And then the third rule, if we have, in the case of where we have 2 Roman numerals, the same, we have the same Roman numeral. Let's say we have CC, it can be CC, it can be XX, it can be VV, yes. So now C is 100. C is 100. So when you have the same Roman numerals, you still add. So we have 100 plus 100, and we are going to have 200. Remember the rules before solving questions under Roman numerals. When the smaller Roman numeral is coming before the bigger one, you subtract the smaller one from the bigger one. When the smaller one is coming after the bigger one, you add the 2 together. And if the 2 Roman numerals are still the same, you still add the 2 together. So that would be all under numeration. The next thing I'll be having revision on is going to be arithmetic. First topic I'll be talking on under arithmetic is going to be addition and subtraction of whole numbers. Addition and subtraction of we'll be talking on addition and subtraction of whole numbers. You all know what are whole numbers. Numbers without decimal points, 0, 1, 2, continuously. Numbers without decimal points are referred to as whole numbers. Now, there are steps in adding or subtracting whole numbers. The first step is to arrange the numbers in column. You arrange in columns, and then 2. You add or subtract, you start adding or subtracting from the right hand side. These are the rules. So now let's take a good look at this example. Example number 1. Let's say you have to add these numbers together. So now we have to follow the steps in adding or subtracting whole numbers. So the solution, the first step is what? To arrange the numbers in column. We have 3,254. We have 3,121, and then 1,223. If you like, you can add the first two. Then whatever you have as your answer, you add it to the next one. Or you sum everything up together, you are still going to arrive at the same answer. So 4 plus 1 is 5. 5 plus 3 is going to give us 8. 5 plus 2, 7. 7 plus 2, 9. 2 plus 1, 3. 3 plus 2, 5. Then we have 3 plus 3, 6 plus 1, 7. So the concept is just for you to get the steps involved when adding or subtracting whole numbers. So that's an example under addition of whole numbers. I'll take one more example under subtraction, then move to the next topic. 2. Subtract 2,122 from 8,353. Solution. The same steps we use in addition is still going to be applied in subtraction. So we have 8,353 minus 2,122. You arrange in columns and then you start adding or subtracting from your right hand side. 3 minus 2, we have 1. 5 minus 2, 3. 3 minus 1, 2. 8 minus 2, 6. So this is our final answer under subtraction. That will be all under addition and subtraction of whole numbers. So the next topic I'll be having revision on under arithmetic is going to be what problems on addition and subtraction of whole numbers. What problems on addition and subtraction and subtraction of whole numbers. There is one thing about word problems. The keyword, what you need to know about word problems is like you need to look at the keywords. If the keyword is either something like sum, in addition, or total, it means this is talking about what? What's it called? Plus, to add. Then, but when it is talking about like the differences, how many is left or take away, you can see from this word, you know that this is talking about what? Subtraction. This is what you need to know about word problem. So we'll be looking at examples Under what problem? Okay, let's take a good look at this example. The sum of 8 and a number is equal to the product of the number and 9. Find the number. So now, the question says the sum of 8 and a number is equal to the product of the number and 9. So we should find the number. We don't know the number, so we have to represent the number using any alphabet of our choice. So in this case, let's use let the number be U. Let the number be U. So now, sum of a number and 8, and that number is represented with letter U. Sum of 8 and U, it means 8 plus U, is equal to the product of that same number and 9, that is 9 times U, which is equal to 9U. So 8 plus U is equal to 9U. 8 will now be equal to 9U. This U is going to cross the equality sign. So we are going to have minus U. 9U minus U, we are going to have 8 to be equal to 9U minus U is going to give us 8U. So U is our unknown. So we divide both sides by 8. 8 divided by 8 is equal to 8U divided by 8. 8 is going to cancel 8. So therefore, our U is equal to 8 divided by 8 is what? 1. So the unknown in this case is 1, which is our U. And that will be 1 for arithmetic. So the next is going to be, the next division of the having is going to be under algebra. Algebra. So in algebra, the first topic I'll be talking about is going to be open sentences. So when you hear the word open sentences, it's a math problem with a missing piece, or it contains either a blank or unknown. It can be true only when the blank or the unknown is substituted. So for example, if you have 7 plus box is equal to 10. In this case, our unknown is the box. And for us to know whether this expression is true, it means we have to provide what is supposed to be inside the box. So let's make the box the subject of the formula. Is equal to 10. So 7 is going to cross the equality sign. It will change from plus to minus. We are going to have minus 7. So our box, which is the unknown, is equal to 10 minus 7 is going to give us 3. So if the box is 3, let's substitute back the value into our questions. Our question, we are going to have 7 plus the box is 3. So instead of writing the box, we are going to substitute in 3. 7 plus 3 is equal to 10. 7 plus 3 gives us 10. So this is a true statement. Let's look at the second example. If you have 12 minus 5 is equal to 15. 12 minus 5, or let's say 12 minus 5 is equal to box. If you are making box the subject of the formula, 12 minus 5 is going to give us what? 7. So it means our unknown in this case is what? 7. So the next topic I will be having a revision on Under algebra is going to be expressions involving brackets. Expressions involving brackets. So there is one thing you need to know about expressions involving brackets. If the expression is coming with a positive sign outside the bracket, you don't need to do anything. You just open the bracket. The sign is still going to remain the same. But in the case of minus, if a negative sign is outside the bracket, it will affect all other signs inside the bracket. So let's expressions involving brackets. Involving brackets. Example. Let's say we are having simplify 4a plus 3b plus a plus b. I said earlier that if it is a positive sign that comes before the bracket, you don't need to bother about it. You just open the bracket. The sign is not going to affect what is inside the bracket. But if the sign outside the bracket is negative, is minus, all the signs inside the bracket is definitely going to change. But then in this case, let's simplify and see. Solution. We have 4a plus 3b plus, you can see that it's not affecting what is inside the bracket, plus the plus is still there, plus a plus b. And do you know why it is not affecting what is inside the bracket? Is this rule. We have plus times plus is equal to plus. Plus times minus is equal to minus. Minus times plus is equal to minus. Minus times minus is equal to plus. So now, if you are having plus multiplying plus, it means you are still going to have what? Plus. But assuming here is minus. Minus times what is the sign inside the bracket? Minus times plus is going to give us what? Minus. So it's going to change the sign inside the bracket. But since it is plus, you don't need to worry about it. Just open the bracket. Now, the next thing to do is to collect the like terms. You collect like terms. We are having 4a, then we are having a. They are like terms, right? So we have 4a plus a. This 3 is having b, and we are having another b. They are also like terms, so we take them to the other side. Plus 3b plus b. So now, we now simplify further. 4a plus a, 5a plus 3b plus b, 4b. But mind you, this is a situation whereby you are having plus outside the bracket. But if it is a minus outside the bracket, all the other signs inside the bracket is going to change. So the next thing I'll be having a revision on is going to be geometry. I believe in geometry, the only topic, though is a broad topic, I cannot say the only topic, is Pythagoras. We've treated all for the whole of this term is Pythagoras rule. Pythagoras rule, using Pythagoras rule to find the unknown length, using Pythagoras rule to find other sides of the, yes. So now, Pythagoras rule is going to be our revision topic, Pythagoras rule. So Pythagoras rule states that in a right angle triangle, the square of the hypotenuse is always equal to the sum of the squares of the other two sides, that is adjacent and opposite. So we have c squared is equal to a squared plus b squared. C squared is your hypotenuse, that is the longest side. Well, let me draw. You have. So this is always the longest side is always the hypotenuse. So Pythagoras rule states that in a right angle triangle, the square of the hypotenuse is always equal to the sum. You sum the square of the other two sides together is going to be equal to what? Your hypotenuse square. Now let's look at this example. Find the length of the hypotenuse if the other two sides are of length 8 cm and 6 cm. Solution. I said the longest side in a right angle triangle is our hypotenuse. So now we have to find the length of the longest side. If the other two sides are being given to be what? 8 cm and 6 cm respectively. So now, and I said we have c square, hypotenuse square is always equal to the sum of the square of the other two sides, that is opposite and adjacent. We have a square plus b square. In this case, what are we looking for? Hypotenuse, which is our c square. So c square is equal to our a square. We have, from the question, we have the other two sides to be what? 8 cm and 6 cm. So 8 square, since the formula is coming with a square, plus the second side is what? 6 cm. We also square it. So 6 square is going to be equal to 8 square is 64 plus 6 square is 36. So 6 square is not going to be equal to 64 plus 36 is going to give us 100. Mind you, we are not looking for c square but what? C. So we take the square root of both sides. Take square root of both sides. So if you are having c square, square root of c square to be equal to square root of 100. So your square root is going to cancel the square. Therefore, your c is equal to square root of 100 is 10. So the length of the hypotenuse is what? 10 centimeter. And that will be all under geometry. So the last thing I'll be having revision on is going to be statistics. Statistics. So in statistics, the first topic I'll be talking about is going to be pictogram. Pictogram is one of the forms of representing data using picture. That is representation of data using pictures. Now, you also have to work with the key when it comes to pictogram. You look at each key, then you multiply the key by the total number of pictures. For example, let's say we have 5 apples in a basket, and then now we have 5 pupils to pick each of these apples inside the basket. And the key is what? For each one apple represents 3 apples. So when I said earlier that we are going to multiply the key by the total number of the pictures. So it means we multiply the key, which is what? 3. Now since 1 apple is representing 3 apples, using the key. So we multiply the key 3 by the total number of the apples inside the basket. That is 3 times 5 to give us 15. We have 5 apples and then we have key. Therefore, you multiply your key by the total number. 3 times 5, which is going to give us 15. So pictogram is the representation of data using pictures, and then we work with key. We multiply the key by the total number of the pictures. So the next topic is going to be bar charts. So bar chart is another form of representing data using bars. Now, let's say, for example, so now we have to find the mean of these numbers. We have 2, 10, 8, 3, and 2. And I said these are the steps we follow to find mean of given number or items. Now, solution. Step one, we have to add all these numbers. We sum them up together. So it means we are going to have mean to be equal to 2 plus 10 plus 8 plus 3 plus 2. That's step one. Then the second step says divide by the total number. So it means you have to count. Okay, let's count. We have 1, 2, 3, 4, and 5. So the total number is 5. So we divide by the total number, which is 5. So mean is going to be equal to, so let's add up these numbers, sum up these numbers together. We have 2 plus 10, it gives us 12 plus 8, that's 20, plus 3, 23, plus 2, that is 25, divided by 5. So therefore it means our mean is equal to 25 divided by 5, we are going to have 5. And that comes to the end of our revision for this term. So thank you all for listening. So if you have any question, comment, so you can drop it in the comment section, or you reach out to me through my WhatsApp line 080-3547-1205.